most welcome to our lectures for operational research subject provided by GTU in 5th semester having a subject code 3151910. Today's we will discuss about the introductory part of an subject operational research. Myself Jambaksh Manik Variaba. I am PhD pursuing in solar energy, working in mechanical department at Government Engineering College, Damman, affiliated with Gujarat Technological University. So for the today's lecture, our content will include teaching and examination scheme, overview, which includes history, World War II, and definitional of OR. When I say OR, it means operational research. The third work part will be fundamentals of operational research, which includes characteristics of OR, phases of OR, scope of OR, and limitations of OR. So let's get started. First, teaching and examination scheme. As we say, the subject code is 3151910, included in 5th semester for mechanical department. It is also in the electrical department, but for the elective subject. So as per the teaching scheme, there will be a 3 lectures, 0 tutorial, 0 practical, and total credit will be of a 3. For examination marks, the theory marks will include end semester examination of 70 marks. For PA, it will be dependent on the college, institute, whether it takes a 30 marks mid-sem or either in their own way. So total of that will include of an 100 marks. So subject will be of 100 marks having a credit of 3. So which books you have to prefer for that? GTU has provided 9 different books for operational research. Among them, 3 are one of my favorites. That is operational research, an introductory part by Hamdi Taha, Pearson Education Inc. The second one is operational research by P. Mariappan Pearson. Third one is operational research by H.N. Wagner Prentice Hall. So these books are very wonderful. The another one are also very good, but I personally myself prefer these 3 books because it is easy for understanding. The other books are also good. You can choose one of your own. Okay, let's moving forward. So the history. Now, human beings since from the beginning are evolving from a simple understanding to a complex system that we know today, right? So how does this thing happen? It happens because we has an complete interaction from the beginning. We interact with different minds, we come to discussion with them, we interact with them, and then we come to the conclusion. So just like that, the second pics also shows you something, a queuing system. You can see this queuing system in no another living being except human itself, because human being has been focusing on queuing system since the beginning time. It is where you can see in the banks, a mall, a bookstore, or anywhere else. You will see a queuing system which provides an first come first some or last serve first some and whatever in the queuing manner. Now, for the transportation, the invention of wheel has always able and human one step forward than the another. But to manage this transportation is one of the question of all time from since then. So all these issues are not solved in one day. So like it says, no science has ever been born on a specific day. Operational research is no exception. Its roots are as old as science and society. Those the roots of OR extend to even early 1800. It was in 1885 when Frederick W. Taylor emphasizes the application of scientific analysis to methods of production that the real start took place. So it means that if any technical aspects comes up, if it's been applied to a methods of certain production, it suddenly becomes an important subject of our understanding. So in this way, operational research also from the beginning has been put a step in our education and understanding. Now, where it actually become a very important part, that when the World War II comes. And this is a picture taken by the some photographer. I had taken it from the gallery of this World War II. Now let's see what happened in World War II. In World War II, the military management in England called on a team of scientists to study the strategic and tactic problems of air and land defense. So it was the management of England that brings the scientists together. This team includes PMS Blackhead of University of Manchester and a former naval officer. This group was called a Blackhead Circus. They include three psychologists, two mathematics physicists, one astrophysicist, one army officer, one surveyor, one general physicist, and two mathematics. So you can see this team is a multidisciplinary team, bring across from different parts to understand certain things. Many of these problems were executive type. Okay, the objective was to find out the most effective allocation of limited military resources to various military operations and to the activities within each operation. So what was the objective? The objective was to put a limited military to a most effective way that it can be optimized at its best. The application include the effective use of newly invented radar, allocation of British Air Force planes to missions, and the determination of best pattern for searching submarines. This was the group which was first called as an OR team. Now the definitions of operational research. OR is an experimental and applied science developed to observing, understanding and predicting the behavior of purposeful man-machine system. So what it is? It is an experimental and applied science. So you have to apply that at a certain point. It is not a research science. It is an applied science. So it develops some observing, understanding and predicting a certain behavior of man and machine system. OR workers are actively engaged in applying this knowledge to practical problems in business, governments and society by OR Society of America. The another one is operational research is a scientific method of providing executive departments with a quantitative basis for decision regarding the operations under their control. So what is it? It is a scientific method for the providing of an executive departments with quantitative basis with some quantity for decision regarding operation research under their control. That is Morse and Kimball. The third one is OR is a management activity pursued in two complementary ways. One half by the free and bold exercise of a common sense untrammeled by any routine, and other half by the application of a repertoire of well established pro-created methods and techniques. Okay, that means it is divided into two parts. Okay, which includes first one, which includes free and a bold exercise of a common sense thing which is untrimmed by any routine. It is a very common sense, there is no routine in between that. The other half by the application of a repertoire of well established pro-created methods and technique, while the other half is what it is very pro-created and methods and techniques are being involved by Jagjit Singh. Now, the last one, the operational research is the application of scientific method, techniques, and tools to problem involving the operations of a system so as to provide this in control of the operation with optimum solutions to the problem. That means it is a scientific method, it is a technique and a tool to problems involving the operations of system so that it provides an operation with an optimum solution. That is very important. See, if something we want in good way, we have to optimize that, so and only the minimum input will go and the maximum output will come. It is given by Churchman, Eckhoff, and Knopf. Now, what are the characteristics of operational research? So, use of entrepreneurial team, complete system orientation, involvement of scientific method, improvement in quality of decision, uncovering hidden problems. So these are the characteristics. Let's talk about first one, interdisciplinary team, use of interdisciplinary team. As we see in the World War II, the team was constructed of a different parts. There was two mathematicians, two physicians, one surveyor, one military man, one army officer. Okay, so this team brings an interdisciplinary part that will bring a certain solution in a different way with an involvement of a knowledge of a different areas. So if you use a single team having a single knowledge, it will be won't useful to you. But having a collective mind from different parts will bring in very wonderful characteristics of an operational research. So complete system orientation includes that the operational research provide a complete orientation. That means it does not part some device in somewhere. See, for an example, if we're talking about transportation or assignment model, they will provide a complete system orientation. They will not halfly give in certain ideas. So it is a complete system orientation. The next one is involvement of scientific method. This operational research brings an involvement of scientific method. For an example, if I say I had to grow a plant, I have ABC soil. So what I will do, I will plant some ABC soil for this particular plant, and I will see which soil is most effective for our plant, and then I will come to the conclusion. So what it indicates that characteristics of operational research is also bring the involvement. Now, improvement in quality of decision, that is important. See, if you do some analysis with technical aspects, then what you will do, you will not bring some irrational values, you will bring in particular expert ideas. So improvement in quality of decisions becomes very crucial for operational research. The last characteristic is uncovering the hidden problem. So whenever we observe something, there are possibilities, then in some of the part there is a hidden problem. Okay, so like an iceberg. See, when a sailor sees an iceberg, the issue is not what it is above, but the issue is what is below. So to see this unhidden problem, it is a characteristics of operational research. Now, phases of operational research. It includes definition of problem, construction of model, solution of the model, validation of the model, implementation of the solution. So let's talk about first definition of a problem. Whenever we visit somewhere or we want to find a certain thing, the first most important part is to understand what is the problem. So it brings out the definition of a problem. So first, the most important part is you have to define the certain problem. Then you have to construct the model. See, model can be anything. It can be a mathematical model, a computational model, or a constructive model, right? But you have to bring this model that will give us an idea of the upcoming thing. So the next part is solution of the model, which includes identification, exploration, set goals. If something is not going way, then you have to find the alternatives, then you have to select from them, then you have to implement, and then you have to evaluate. Then validation of a model. If we construct something, for an example, if I construct a mathematical model, I have to then validate with some real practical life. Okay, that is important. Otherwise it is not a good idea to just evaluate in one part and then come to the conclusion. It might take a wrong decision. So you have to validate the model whatever you had constructed, either mathematical or computer or the actual experiment, and then you have to validate it. After that, you have to implementation of the solution, which is very important. If the validation has been correct, then you have to implement that. Okay, otherwise it will be just a theoretical part of your side. So these are the phases of operational research. Now, scope of operational research. So it used in industry, in defense, planning, agriculture, and public utilities. So in industry, like we had one definition which says that when the understanding of operational research becomes a techniques in the creations or productions of our products. So the applications are in industry also, that operational research help in our industry. Then we talk about in World War II, it of course helps in defense, then it helps in planning, then it's agriculture, then public utilities. So anywhere in the, so there is a vast scope of operational research. There is a vast area that can covered up by operational research. The last of our topic is limitations of operational research, which includes magnitude of competition, non-quantifiable factor, distance between managerial and operational research, money and time cost, and last, implementation. So first of all, magnitude of a computation. What that means, see, if we are talking or taking any technical aspect, then of course what will happen, we had to compute so many datas. So what will it will do, it will increase in magnitude of computations, okay, that you have to calculate. So it will increase the size of an computation. The second one is non-quantifiable factor. See, sometimes there are some factors which are completely useless, we don't have to consider, but at a time of calculation we consider that. Okay, so it brings some non-quantifiable factor. Then distance between manager and operational research. Sometimes whatever the outcome has been provided by this study does not mean that it is going to be a perfect idea for the manager or workers over there. So it brings some differentiation between them. Then money and time cost. See, of course, if it's a computational thing, then you need mind and work. So it brings an extra money and time cost in this particular our study. Implementation. If we had find out certain solution for the problem, then to implement that is a whole different aspect. Okay, maybe it is possible to implement, maybe not, but sometimes implementation is so difficult in this scenario. Okay, so over here, let's end our introductory part to our subject. I hope I had clear myself. Thank you so much. If you had any question or any query, please ask me in the comment section. Would like to help you. Thank you.